I'm just a jerk.
Well, you can
Because
turn off all cellular and you have to be on Wi-Fi.
yeah.
But then why pay $100 just to turn it off? All right, because I'm rich. I'm a teacher. All right, so what I want for you to do, please, on your notes, read everything above example 1. Take a few moments and read everything above example 1. The whole point of why I put this on here is because I don't feel like I gave you enough of an explanation last week as to why we would even care to do this, okay? But I feel like this line right here kind of sums it up. Although parametric equations, that's the it in this sentence, although parametric equations, or most equations tell you where the object has been, they do not tell you when the object was at a given point, okay? Normal equations, it tells you where, but it doesn't tell you when. And sometimes that can be really important, okay? So in parametric equations, we add an actual parameter of time to track where it's been and when, okay? So I just wanted to put a little bit more explanation in there of why we use parametric equations. All right, let's just pop down to example 1. This is what we did last time. So I'm going to give you a few moments to go back through that example and try it on your own. Then we'll come back together and we'll try it all together. But I want you to get as far as you can from last time's stuff. Go. What you doing, Boo? Finished reading. How'd you do that?
I said finished reading.
Your magic. You can read through your eyelids. Do example 1. Oh, okay.
Is that your thing? Is that yours?
What? He's recording.
No, thank you. I have plenty. Nay?
Oh, I was gonna tell you. I was gonna tell you when you first came in, so you don't say anything. I'm good.
Fair enough.
Can't do that.
Did you go home and read more about that? Okay.
Wait, Miss. Equal to. Okay. That makes sense.
You can go to other plant-based proteins. Pea protein? Peas?
Oh.
So like they sell little packets of pea protein that you can add in like your drinks. That it makes it kind of taste a little chalky, but that's another way. Kind of.
Like pea?
It doesn't taste PEA like the vegetable, the starchy vegetable.
I hate pea.
Oops.
Y'all are my video girls.
Okay.
There you go. Okay.
I have a feeling you're gonna have to break your legs a few times, space them out, and grow your bones together to be
The
as tall as.
doctor should have lied to me. They showed supposed to be 5'11", 180 by sophomore year.
How many inches do you still need to grow?
4.
Okay.
I broke the growth plate.
The growth chart?
Yeah.
Yeah. Okay. He said it like deadpan. I broke the growth plate. Yeah. All right, here we go. Let's go over it. You're either stuck or you're done. All right. So what is the importance of this piece right here? Tells me my t values. So my t values are -2, -1, 0, 1, 2, and 3. This time I made sure to put enough columns. All right, so what do I do to get the second column? Or the second row?
Square T.
I plug these into X, right? It's the X row, I plug it in there. You are typically awful at plugging in negative numbers and squaring them in your calculator. So, everybody really quickly for me, please. Second plus 712, because we messed with your calculators last time.
What?
Second plus 712. So that you clear it. That way it shows up well, like shows up how it's supposed to. Is that better or worse? Can you see that better? Okay. So what I recommend is you going to y equals and putting in x squared minus 4 and then going to your table and having it tell you your negative numbers. You will get it right that way. Yes, it's cheating, but you'll get it right. So -2 squared minus 4. So let's go up to -2. That's 0. -1, -3. 0, -4. 1, -3. I heard an epiphany there. 2, 0, 3, 5. That 5 is like my daughter's. I apologize. Okay. Now, how do I get this bottom row?
Multiply.
Divide by 2.
I plug what into y? I plug t's into y. So if you need help with that, alpha y equals 1 gets you the fraction. X over 2. There you go. So it looks like to me I get -1, -0.5, 0, 0.5, 1, 1.5. Right? I just pulled those out of my table. Alright, so let's go graph these points now. Remember, you take this xy pair. The x is 0, the y is -1, bless you. And that is the point that we're actually graphing. So you take each of these points and graph them. 0, -1, -3, -0.5, -4, 0, -3, +0.5, 0, 1, and 1, 2, 3, 4, 5, 1.5. It is a horizontal parabola, yes. Boom. Now, last class I told you that indicating the direction that your graph traveled was important. But then a couple of kids today have been like, how do I know which way it's going? Which point did we plot first? 0, -1. And then where do we go from there? To the left. So we graphed them as time passed in this direction. So you graph them as you plot them. Okay? The way that parametric equations were explained to me is, what if you put a little ladybug on your piece of paper and tracked how it walked? You'd want to know the way that it walked. So I don't know if that helps. Now, what does it mean when I have to eliminate a parameter? Get rid of t. I'm really trying to write an equation where y is a function of x, right? So which equation did I start with? X. x is equal to t squared minus 4. I'm solving for t here. What do I do first? Add 4. So t squared is equal to x plus 4. Yeah, I cancel out the squared by square rooting, and most of you are going to leave it like this, and I'm going to count points off.
Plus or minus.
Plus or minus. Anytime you apply a square root, you have to do plus or minus. We talked about y last time. All right, now that I have t, what do I do with that?
Plug it into y.
I'm going to plug it into y. So y is t, or plus or minus the root of x plus 4 over 2.
Oh, that's the answer?
That's your equation, yes. Now we talked about last time why it was so important to have that plus or minus. So if I go put this in, and I do the positive square root of x plus 4 over 2, notice that that's just giving me the top. It isn't until I go in and I put in negative that it gives me the bottom. Okay? Questions on example 1? This is so much fun, Miss Cleveland. Yes?
Why is it when you put it in the calculator, it's a couple times when you do it on here, you just do part? Is it because the restrictions on t?
It is not because of the restrictions on t. It is because that this is a function of y. And think about the word function. What does function imply? An input and output, but it implies that it passes the vertical line test. So here for the positive version, in order to make this a function, okay, let's do it this way. Based on the conic sections that we've been talking about this time, we would call this a horizontal parabola, right? What variable have we been using as being squared? If it's a horizontal parabola, which variable is squared? Y. But in this equation, it's not. Let's see where that comes from. Let's just get crazy. You won't have to do this on your test, but I'm just getting excited. Okay. So I'm going to multiply both sides by 2. I'm trying to solve for x now to prove a point. 2y is equal to plus or minus the square root of x plus 4. What would I do to get rid of the square? Square root, I would square it. Now what happens when you square a number? Is this plus or minus needed?
No.
Why?
If you're not taking the root.
When you square a positive, it's positive. When you square a negative, it's... So regardless, our answer is going to be positive. So here, this is... Right, and then I can subtract 4. And I have 4y squared minus 1 equals x. So now I have this as a function of y squared. So the reason why it can't graph both of those is because the thing that we enter into y squared is the x. So when you do that, it only gives you 1/2 of it. That's where the plus or minus things are. Okay? Way more than you probably wanted to know. Okay? Other questions about the original one? This right here is a perfect example of what you could be expected to do on a test. Okay? I would feel very comfortable with this being on a test. Worded and looking exactly like this. Flip over to the back or to the next. For you, you don't have to flip over. The way that I copied y'all's. Okay. I'm not going to use these calculator instructions just yet. They're there for when we need them in a moment. Let's go ahead and jump to example 2.
Oh, 2.
There are 2 of them there. An A and a B. All right. Let's look at these 2 equations right here. I want us to be very careful. Here, this doesn't say x equals like it normally does. So that's probably one place we need to get started and do that, yeah?
Mm-hmm.
What's going on over here in the second equation?
A lot.
How is that different than before?
Weren't you solving?
Go back and look at your first equations. Go back and look at your first equations and tell me how it's different here. Ryan, you need to stand up, homeschool it.
There's no T.
Okay. Alea, there's no T. Get it, girl. Get it. Okay, so you can sit back down now. That's creepy, man. Thank you. Okay. All right. So here, this one's weird, right? This one isn't solved for x, and this one doesn't have a T. So let's see what we have to do. Let's go ahead and solve this one for x. What would I have to do?
Multiply both sides by 2.
I'd have to multiply both sides by 2, right, to cancel out that 2. So x is equal to 2t. That's fine. That's normal. We'll deal with y in just a moment. Oh, wait, I'll fix the camera. Okay, sorry, thanks. All right. Okay. All right, so let's go ahead and get started. I told you what t's to use. So -2, -1, 0, 1, 2, 3. And I'm going to plug those into the x equation. Well, 2 times -2, -4, times -1, -2, times 0, 0. 2 times 1 is 2. 2 times 2 is 4. And 2 times 3 is 6. Y'all should feel very comfortable with that first row. But let's go back to that y equation. What is the input? X, not t. X, not t. You're with me?
Yes.
So, just for our purposes here, because I could feel like it would be hard to do this, I am going to, first off, I'm going to do, so that I don't square negative numbers incorrectly, I'm going to go put that in y equals. How do I get a fraction? Alpha y equals 1, 1/4 x squared minus alpha y equals 1, 3/2 x plus 9. I'm entering that in so that I know that my negatives are squared appropriately. And I'm going to go look at my table. Oh, I'm going to go look at my table. Now, I'm going to cover up the t row because I don't care about the t row for a moment. I am plugging in x's because you all told me that that's what the variable was, yes?
Mm-hmm.
All right, so here we go. I'm looking for x equals -4. That's 19. And x equals -2. What do y'all get there? Thank you. Some people are doing this. Thank you. 0, I got 9. 2, I got 7. 4, I got 7. And 6, I got 9. Okay, so I just pulled those out of my calculator really quickly. Again, by putting it into your table, you don't have to punch it in every single time. It's a way of working smarter, not harder. I'm still gonna graph, and y'all can't really see your graph as well as I can, I think. This is what the graph is supposed to look like. So it doesn't have much below the y-axis. So I would be graphing the point -4, 19. 1, 2, 3, 4, 2, 4, 6, 8, 10, 12, 14, 16, 19. -2, 13. Somewhere in there. 2, 7, 4, 7, 6, 9. Okay, so I don't know about you, but I think it's supposed to kind of look like a parabola, but I really like some confirmation in my calculator to see what it's supposed to look like. Yes, no?
Yes.
Okay, so this is where those steps up there come into play. Please follow along. I'm only saying this once. All right, notice up there in step 1, it says set your calculator to parametric mode. Well, everybody press mode. And you'll notice we've got the func. Okay, we're in function mode. It's a tough crowd. For this one, we want to be in parametric mode. But pause. While I have this up, also I want you to go look at your X key. When we're working in functions, what variable do we always use?
X.
When we're working in parametrics, what variable do we use?
T.
T. It's like our calculator knew what was going on there. When we get to polar coordinates next unit, we're going to be using theta. And when we get to sequences and series, I think it's unit 10 or maybe unit 11, we'll be using n. So like your calculator already knows what's up. All right, so let's go down and make sure that you have clicked enter over par so that parametric is selected. Now everybody go put your y equals button and see how different that looks.
Whoa, okay.
Like what? Okay, what's going on here? Well, here's our x equation, and here's our y equation. This is telling me that t is the variable. Okay, so let's put in our x equation. What's our x equation for this one? 2t. So everybody type in 2t.
Oh.
Right? Pretty cool. Yeah, yeah. All right, this is where we've got to be a little bit tricky because what is the variable in the second equation? X, not t, right? So everywhere we see an x, we have to put in 2t. You with me there? So here we go. Alpha y equals 1, 1/4, parentheses, what does x actually equal?
2t.
2t, close parentheses and square it. Minus alpha y equals 1, 3/2, parenthesis, what is x?
2t.
2t, close parenthesis, plus 9. So I have my x equation and I have my y equation in there. This is so exciting. Okay. Now what does it say up there in your sets of instructions?
Go to y equals.
We have to go set the window. So after you've entered in your equations, go to window. I just have some crazy values in there. I don't know what I have in there yet. All right, what do you think T-min means? Your minimum T value. What minimum T value do we care about?
-2.
-2. So -2, enter. What do you think T-max means?
3.
Your maximum, so in this case, 3. Your T-step, that sounds like a dance move. T-step. It's like 2-step. Okay. T-step, the smaller that number, the better your graph will be because that means that it's counting more T's along the way. So I'm just going to leave it at what it is. 0.1 is fine. Okay? X-min. What is the smallest X value we're dealing with?
-0.
Hold on. -4. So -10 is fine, right? Like we'll be able to see it. What's the largest X value?
6.
6, so 10 is fine. What do you think XCSL stands for? X scale, that's what your X is counting by. I want it to count by 1, so that's fine. Y min, what's our smallest Y? 7, but on this graph right here, if I'm wanting it to look like this, I don't care about negative numbers. I'm just going to have it be 0. Yeah? What is our maximum Y? 19, so I need to go up to like 20 to make sure I see everything. And my Y scale, I'm okay with it counting by 1. Questions about any of the values I just entered? Now go ahead, graph. Oh yeah. Does that look like the one that we kind of graphed?
Yes.
Good. That's what you want to have happen. Oh, Miss Cleveland, that's what you call beautiful. Some of y'all have such judgy faces when I do stuff like that. Any questions about the process I just did there? Do it again?
Yeah.
Okay. All right, let's try it again then. Where did I start? What do I have to do first? I need to get this as an equation of x as a function of t. So what am I going to do? Well, I personally, I would add x and then subtract a t. So I don't have to divide by negative numbers. So basically these just end up switching spots. So x is equal to 2 minus t. Yeah?
Mm-hmm.
Okay. Again, I said my t's are just going to be the regular -2, -1, 0, 1, 2, 3. If you feel the need to put this into your calculator, if you enter these back in, you have to go back and change your mode back to function and then enter it in. 2 minus x. Okay, if you're just trying to get whatever the t values are there, change it back to function. So let's see, -2, what does this give me? 4, -1 is 3, 0 is 2, 1, 0, -1. This is where I have to be careful. This is y as a function of x. So what is my input? X. So when I go to my calculator, alpha y equals 1, 1 over 2x. And I go to my table. I am looking at the second row now. I don't care about the first row for this. So 4, I have 1/8. Do y'all see where I got that? And 3, I got 1/6. And 2, I got 1/4. 1, I got 1/2. Okay, why would I get error on 2 or on 0? Okay, yeah. If I plugged in a 0 to this, what's 2 times 0?
0.
And what's 1 divided by 0?
0.
Undefined. We cannot divide by 0, right? Now, anytime your calculator gives you an error or undefined, what does that mean graphically? I haven't heard it yet. What kind of straight line? A vertical.
Infinite.
What's the word I'm looking for? It's a dotted vertical line. What do we call it? Oh, yes, Boo. A vertical asymptote. Anytime your calculator gives you an error, that is indicating on your graph that you have a vertical asymptote. And then when we have -1, I'm down to -1/2. All right, so I'm going to plot these points. 1, 2, 3, 4, and an 8. I see 3 and a 6. Is a 6th or an 8th bigger? 6th is bigger, so we're like a little bit further up. Is a 6th or a 4th bigger?
4.
4th. Half is bigger. And then undefined, so I have a vertical asymptote. And then -1, -1/2. I don't know about you, but that's not a lot to go on. I'd like to know a little bit more about what this is doing. I have a hunch of maybe what it's doing, but I'd really like to be sure, especially if this were a test. So let's practice our calculator skills again. If we're gonna enter parametrics into our calculator, what do I have to do first?
Mode.
I've got to make sure I'm in parametric mode. Okay, then I go to y equals and clear out whatever mess was in there. X equation, what am I gonna enter in for the x equation?
2t.
No,
2 minus t.
2 minus t. All right, now we have to be careful because there are no t's in my y. So alpha y equals 1. 1 over 2, what is x?
2 minus t.
Parenthesis 2 minus t. Let me go check my window, make sure my window is going to be okay for us. If you never know what to put your window, count your graph. ISO 1, 2, 3, 4. So I'm going to make this go -2 to 3, that's fine. Counting as little as possible. On the graph that you have in front of you, the littlest value is -4. So I'm going to make that -4. Then I'm going to count my biggest value. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to make this an 8. Counting by ones is fine. My lowest y is 1, 2, 3, 4, -5. And my biggest y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And counting by ones is fine. Graph. Oh, okay, that's what this is supposed to look like.
Wow.
Okay, just by plotting a few points, we wouldn't have got there, I don't think. I'd had all kinds of crazy mess on that test. Okay, but here's a way that you can double check it in the calculator. So it looks like you have that vertical asymptote. Oh, we're supposed to stop at 3. Okay, here. But as I graphed this, it went in this direction, right? Right, that's the order in which I graphed it. Oh, we didn't do order over here. -4, 19, it went like this. Looking at my t values, it kind of tracked that way. So just make sure you graph your direction. There you go. Example 2 is a perfectly reasonable thing for you to be able to do on the test. So put a little star next to it saying, you know what? Ms. Cleveland said I should know this. Stuff like this is going to be on my test. Questions? All right, this is the last one that I'm going to hold you personally accountable for. After that, I'm just going to show you how beautiful math is, and you can just watch, and then I'll give you your homework, okay? Do y'all need a brain break?
Yes.
You've got approximately 1 minute to stand up, wiggle out, check your phone, do what you got to do, because I can tell y'all are fading on me. That's more than a minute! Hurry up.
I just want to go to sleep.
A long day. It's you moving her camera.
No, it's
Because every
not.
time you slam your phone on your desk, and when you were writing, it kept making her phone go down. Because your paper's pushing the bucket.
Like that?
Yeah.
Interesting.
Hey, vlog.
Wow.
All right, make your ways back to your seats, please. Phones need to go back in your backpack. another perfectly acceptable one that you should be able to do independently for a test. This is example application because I guess I didn't feel like it needed to be numbered. Sorry. You can put a 2.5 if you're really passionate about it having a number. All right, example application. Let's say that I'm walking to the front of the room, which technically that's the front of the room by Keller standards because that's where the door is, okay? So look at my graph right here. Up here, this line right here is considered the front of my room, okay? And I'm standing over here somewhere. I am going to walk across the classroom. X is going to be my left to right movement. Y is going to be my vertical movement to the other side of the room. And we need to model this situation. So let's think about, I didn't tell you what t's to use here. So what would be some reasonable t values?
0, 1, 2, 3.
Okay, why would you pick those?
3 seconds.
3 seconds, okay, good. Why did you start with 0?
Because you're not moving.
I want to know where I started, right? Why didn't we pick any negative values?
It doesn't start there.
It doesn't make sense, right? Like, that would, in the past, that is, so, yes, I agree with you. I would want to pick 0, 1, 2, and 3. I like those values. Now let's go look at our equations. Ooh, life is good. Why is life good here?
The X's and Y's are on the left.
X's and Y's are already solved for, and look at the equations.
T.
Both of them have t's. So life is super easy here. I can stay in parametric mode the whole time, and I can just enter in the equations exactly as I see them. So here, x is equal to t minus 2, and y is equal to 2t plus 1. Oop, I did that all wrong. 2t plus 1. You all with me there? Okay, now let's go to our table. And when x is 0, or excuse me, when t is 0, I show that I have the point -2, 1. Do you all see where I got that? So -2, 1. And when t is 1, I see -1, 3. Go with me there. And 2, what do we have for 2?
0, 5,
0, 5. And for 3?
1, 7.
1, 7. I just pulled those values right out of my table. Now we're going to treat these like we always have. I'm going to graph the xy coordinates here. So my first one's going to be the -2, 1. -2, 1. -1, 3. 0, 5. And 1, 7. Alright, so I'm making my way to the front of the room as time passes. Where am I in my room at 2 seconds?
0,
5.
I'm going to be at a coordinate point, right? At my x coordinate, I'm at 0. I haven't moved any left or right. My y coordinate, I'm 5 feet or whatever our unit is here from where I started. So at time t, I'm at the point 0, 5. At time t equals 2, I'm at 0, 5. At what time will I be standing at the front of the room?
4 seconds.
How'd we get there?
You did go over 1 up to.
What's my slope?
1.
I'm increasing about 2 units per second. So if I go up 2 over 1, up 2 over 1, I'm there. Well, here was 0 seconds, 1 second, 2 seconds, 3 seconds. At 4 seconds, I'll be standing at the front of the room. I'm fast. These long legs of mine. Okay, some giggles out there. Tough crowd. What does it mean to eliminate the parameter? Get rid of t. Which equation do I start with? X. I'm going to come over here to do my work. It gives me a little bit more space. So if I'm solving for t in this first equation, in the x equation, what am I going to do? Add 2. so t is equal to x plus 2. Then once I have that solved for 2t, what do I do there?
Put in
Plug it into the y equation. So this right here substitutes in for this t. So I have y is equal to 2t plus 1. Then I simplify. So what would I do next?
Distribute.
Distribute. So y is equal to 2x plus 4 plus 1. So my final parameter, or without the parameter t, is y equals 2x plus 5. Now it's always an excellent idea to go back and make sure that that actually does fit. Here in slope-intercept form, what would be my y-intercept? 5, right? The b. Is it crossing at 5? Life is good. What does this 2 represent? Is it going up 2 over 1, up 2 over 1?
Yes.
Okay, so I'm pretty confident that I did what I was supposed to. I am going to make you help me fill out this table. So at this point, I'm not going to make one on the test like this. The state of Texas says I have to teach you. They don't say I have to test you. Okay? So if you want to put your pencils down and just watch, if you're on your phones, I'm going to be upset with you. This is where I feel like all this really gets beautiful. I'm about to geek out on you.
Oh my.
I'm just giving you that warning right now. Okay? All right, this, think back to your unit circle. Cosine was which variable?
X.
Sine was?
Y.
Ooh, be still my heart. We're already starting off really good. No? Okay. So, 0. What is the cosine of 0? At 0 degrees, 1. So 1 times 2 is 2. 2 plus 3, 5.
Oh my.
At pi over 2, what is cosine? 0. I haven't moved any left or right. So 0 times 2 is 0. 0 plus 3 is 3. At pi, what is the x coordinate? -1. So -1 times 2 is -2 plus 3 gives me a 1. 3 pi over 2, what's my x coordinate? 0. So this is 3. And back at 2 pi,
1.
so we're back at the same place as 0, so 5.
Oh.
Okay? Remembering our unit circles. Okay, sine. What is the sine of 0? Which one? What is the y?
0.
0. 0 times 3
0.
minus 1, -1. Pi over 2. 1 times 3 is 3 minus 1 is 2. Pi,
0. 1.
so this is -1. 3 pi over 2, -1, so this is going to be -4. And back at 2 pi. -1. So it's 0, but yeah. Okay, so let's plot these points. This is where it gets really exciting, guys. -5, or no, excuse me, 5, -1, 3, 2, 1, -1, 3, 1, 2, 3, 4, and 5, 1.
It's an ellipse.
It is an ellipse. Now, how did that happen? What a coincidence, right? Why would I put parametric equations with the conic sections unit?
Because we've already talked about ellipses.
Okay, so I did that. Let's eliminate a parameter here and see what's going on. So I'm going to take x equals 3 plus 2 cosine t. What would I do to solve this guy? Ooh, subtract 2, or 3, excuse me, subtract 3. So I have x minus 3 is equal to 2 cosine t. Divide by 2. Cosine t equals x minus 3 over 2. Man, that sure does look something really similar to what we did with ellipses. That looks so close. What's missing over here? Well, let's just square both sides. Let's see what happens. I'm totally leading you in the right direction. So I have cosine squared t is equal to x minus 3 quantity squared over 2 squared, which is 4. That looks very elliptical in nature. Okay, good. But I'm just gonna leave it where it is, and I'm gonna go work on the other side. Y equals -1 plus 3 sine t. Help me out. What would I do here to get t by itself? I'd add a 1. So y plus 1 is equal to 3 sine t. I divide by a 3. Oh, this is looking very elliptical. Thank you. Yes, I approve. Except, man, it's not quite there. What's it missing? Let's just square both sides. Let's get crazy. So sine squared t is equal to y plus 1 quantity squared over 9. Oh my goodness.
If we do that, do we get extra credit?
Don't get crazy. So, like, there's so much stuff that looks like it could happen here. Well, back in Unit 4, which was your favorite unit of all of pre-cal, in our Pythagorean identities unit, wasn't there something about cosine squareds and sine squareds?
Don't give me man flashbacks.
Watch your language. Wasn't there some type of Pythagorean identity with cosine squareds and sine squareds? Sine squared plus cosine squared equals
No, oh my goodness.
1. So what happens if I add these together, just for funsies? If I did cosine squared t plus sine squared t, that's supposed to equal 1, right?
No way.
What is cosine squared? X minus 3 squared over 4. Plus, well, what is sine squared?
What?
Y plus 1 squared over 9. And ellipses are always equal to 1s. What?
These are like Lego pieces.
Pythagorean identities and unit circles and conic sections and parametric equations all connect? No way!
It's an ellipse.
I'm getting so flustered over here. I'm coughing again.
Well, that's crazy.
That's beautiful.
That's gorgeous.
That was so fitting for Valentine's Day today.
Wow.
What?
Okay, let's not go
You
too
made like
crazy.
an ellipse like a heart. That'd be cool.
Those are called cartoids, and we'll get there.
Okay.
Not today.
We're making hearts.
Next unit we will. Okay, so I'm not going to make you do this on the test, but come on, that's kind of cool. That is kind of cool. Like, everything I've taught you just kind of came together in this one beautiful problem.
Bro, how did the person like think that?
That's kind of cool. Chicken or egg, which one came first? I don't know.
Chicken.
This,
Y'all can't appreciate this a little bit for me right now?
Miss Cleveland, how did the person like
Thank you. Thank you. I'll be here all week. Now, you may want to pay attention to the next one.
how did like the person like create all that?
Some old dude was sitting around back in the day and was like, what happens? And boom, lo and behold, Pythagorean identities and conic sections. Now, the next one's not on your test, but I might pay attention. So using the fact that cosine squared t plus sine squared t equals 1, let's go from our conic section form, or our rectangular coordinates, into our parametric equations. Go from rectangular coordinates, where you have x's and y's, to parametric equations, where you have x, y's, and t's.
Oh, I already know where this is going.
You know where this is going, and you're already thinking it's beautiful, yes? We're unzipping the last problem. Like, this was like, zip, zzz. Okay? Okay, so which trig function is x? So let's set this whole business right here equal to cosine squared t. And then over here, which trig function is y? Let's just get excited and set this equal to sine squared t. This is so fun. Okay, but I need to get x by itself. That's my goal here. What do I need to do? Let's square root. Excellent. Because the square root's going to cancel with the square, right? So I have x plus 5 over, careful, what goes on bottom? 3, right? Square root of 9 is 3. And over here I just have a normal cosine t. Multiply both sides by 3. Final step, subtract by 5. Ohms, x is equal to 3 cosine t minus 5. There is the x coordinate in parametric form. What am I going to do on the y side? Square root. Yes. So y minus 2 over, what is it going to be over? 4 is equal to sine t. Get rid of that denominator, so multiply both sides by 4. Final step, add 2. Y is equal to 4 sine t plus 2. Ohms. I know, right? Isn't this beautiful?
Do you have to do that on the test?
No.
Oh, is this still for test learning?
Yes.
Gotcha.
This is, State of Texas tells me I need to teach you this. Now, I won't make us go through this, but if you want something fun to do tonight, example 5 is like where it's at, my friends. Remember the Pythagorean identity?
No.
Okay, let's just stop right there. No. 1 plus tangent squared equals secant squared x, or secant squared equals 1 plus tangent squared x. And when we move tangent squared over to one side, it equaled 1. What do you think this, if we were to derive it, is going to give me the equation of? Which one subtracts? A hyperbola.
Oh.
This would derive to give me the hyperbola. Okay? Don't break my heart like that. So there you go.
It's a tough crowd.